We're going to launch right into the weather and outlook for climate outlook for this winter. Our new one of our newer forecasters, Nathan Patrick, who actually came to us from the National Water Center. He's got experience with this analysis of record for calibration. He's skilled with large data sets and really manipulating them and analyzing them and really extracting the value out of them. He's been very valuable with that effort this summer. He's also one of our co-climate focal points, so he's going to present this next section to you. So, Nate, do you want me to advance the slides, or are you able to do that?
I can do it, Alan.
Okay.
Just give me 1 second here. Okay, if you guys can see me, is that correct?
Yes.
Okay. Okay, so I'm going to talk briefly about the winter outlook overview and what we're expecting this winter. I thought since everything was so crazy this year, I'd recap water year 2020 and see where we started this water year and what last year's water year looked like. I'll do a brief ENSO overview. We'll look at the Climate Prediction Center's winter outlook, and then just one slide on possible impacts on California, and then we'll summarize things up. So just to move forward, to recap what happened in water year 2020, at the start of water year 2020, most of California had recovered from the previous ongoing statewide drought, with nearly 90% of California exhibiting no drought conditions. This was a result of water year 2019 providing a wet winter and a wet spring, particularly in May of 2019. We had a really wet May. Along with water year 2017, this widespread precipitation allowed California to recover from drought conditions. For water year 2020, precipitation over much of Northern California and Central California was between 50 and 70% of average. Southern California fared a little bit better. That was due to some spring storms, particularly in April and May. Looking at cumulative precipitation plots, we can see the progression of precip throughout the year using the Northern, Central, and Southern Sierra station indexes. The light blue portion here indicate the 1966 to 2015 average precipitation. And what we can see here, this is 2019, 2020, these black lines, it's hitting on my screen here. They show that basically we are well below average for water year 2020. And that's primarily due because the fall started off really dry. And then, things turned promising at the start of December. We had some good precipitation come through, but January and February, with February being basically the driest February on record for most of California. We recovered a little bit in March. We had some storms finally coming in, but that deficit was to the point where we were not able to really recover for the annual precipitation. So where we currently are, as of October 6th, about 70% of the state is now experiencing drought conditions, with another 15% experiencing abnormally dry conditions. The drought conditions are more pronounced here in Northern California, dipping down slightly into Central California. And looking at reservoir conditions, we can see that reservoirs in Northern California are about at half capacity and about 80% of normal for this time of year. In Central and Southern California, reservoirs are doing a little bit better. They're still about half capacity, but they're near their historical norm or average at this time. So a brief overview on ENSO. ENSO is a fluctuation in sea surface temperature and the air pressure of the overlying atmosphere in the equatorial Pacific Ocean. The La Niñas are characterized typically by below normal sea surface temperatures in the eastern Pacific, while El Niños are typically characterized by warm sea surface temperatures in that same region in the eastern Pacific. So we have two examples here of two of the stronger ENSO events, the La Nina event of 1988 and then the El Nino event of 1997. Different regions are used to calculate different ENSO indexes. One of the most common regions used by the Climate Prediction Center is NINO 3.4. NINO 3.4 sea surface temperatures are averaged over the 3 months ending with the current month, and then that value is called the Oceanic NINO Index. If the ONI exhibits warm or cool phase conditions for at least 5 consecutive values, it officially becomes an El Nino or a La Nina event. Typically, computed indexes less than a -0.5 are classified as La Ninas, and indexes over 0.5 are El Ninos. So looking at the typical ENSO patterns, shown here are the typical patterns for North America. The key difference really are the jet stream changes, the storm track locations, and the variability. With the La Nina pattern, we tend to sometimes have this blocking high pressure out here over the Pacific that tends to drive the polar jet stream further north near Alaska. And in La Nina years, or sorry, I got them backwards. Sorry, I did not read this correctly. In La Nina years, the high pressure builds and this drives the polar jet stream further north. Whereas in the El Nino years, we basically get this steady stream where the storm tracks are really favorable to move through Southern California and the Southern United States. This slide shows the relationship of October to March precipitation with the previous June to November of the Southern Oscillation Index for California. Here's the statewide plot, and then over here on the right, we have smaller plots showing different regions, breaking it down from the northern part of California down to the southern part of California. So far this year, if you were to compute the Southern Oscillation Index, it's 0.5. June was a little negative, but since then it's been positive, and the overall average, as I said, is 0.5. And so this would seem to suggest that La Nina conditions are in place. So just to explain this plot a little bit, the La Ninas are indicated by blue dots or a positive SOI. The El Ninos are represented by the red dots, the negative SOI, and then the green dots are the neutral conditions. The further to the left you go and the further to the right you go, the stronger the ENSO condition for the respective La Nina or El Nino. And so just looking at all of these plots, you can see that the key takeaways is there's a lot of variability and relatively weak correlations overall. El Ninos tend to have more spread compared to La Ninas. La Nina precipitation in Southern California, if you look down here, it's a little bit more clustered together with less spread. So maybe perhaps a little bit better signal there. But mean El Nino precipitation for all events, all years going back to 1933 and 1934 is slightly above the mean for all years. And same thing, the mean La Nina precipitation for La Nina years is below the mean of all years. The one exception is if you actually look at the North Coast up here, you can actually see where the La Nina precipitation actually is slightly above the neutral conditions.
Hey, Nate, we are running a little short on time. If you can try and wrap
I will. Okay, I'll speed it up. I only got, I think, 3 slides left, roughly. Okay, so Climate Prediction Center has issued a La Nina advisory. The sea surface temperature anomalies on the week center around September 30th show this well in place, as well as all the sea surface temperature anomalies for the different indexes are also indicating La Nina conditions. This is the model predictions of ENSO from the September 2020 issuance. Majority of the models in the CPC plume are predicting the La Nina to persist through winter and to weaken during the spring. The latest forecast from several models, including the CFS, suggests the likelihood of a moderate or even strong La Nina, and the forecasting consensus looking at the atmosphere coupling also supports that viewpoint. They did mention yesterday, we did get a briefing, that the vertical heat coupling in the ocean or vertical heat structure throughout the Eastern Pacific is not as strong as they indicated, and it's not actually weakening or increasing in strength. So there is some indication that perhaps maybe this La Nina might be weaker than initially thought. So past La Ninas really quickly, what we see here is in the 2007, 2010, and 2005, we actually had relatively wet conditions over California, where if you look at 2008, 2011, and then 01 La Nina, it was tended to be dry. So moving forward with the CP temperature outlook, this was just released today. Probabilities are basically, this is from now until December, above the preferences for above normal temperatures. And then this is December, January, February, once again, above normal temperatures persisting. And then looking at the precip, we basically are expecting below normal precipitation from now until December, and then also then through winter as well. And so the potential California impacts is we think drought is going to continue. It's probably going to set up more here in Southern California, and then in far Northern California, perhaps if we do get some wetter precipitation as the storm tracks maybe come in, it may reduce the drought slightly in Northern California. And one thing to point out on our website, depending on storms coming in and the heavy intensity precipitation, this is a product that we now put out for the burn scars. And so we have it for 18, 19, and 20, where you can actually look at the probability of debris flows flooding. So that might be something that you might be interested in checking out on our website. And so these are basically the conclusions. The La Nina advisory has been issued by CPC and is likely to continue through winter and the spring. All past La Ninas exhibit variability. Some have been wet and some have been dry, so it's not quite sure what's going to happen. It really depends on how storm tracks set up. Generally, though, Southern California tends to have drier winters, and far Northern California can have normal to above normal precipitation. Normal temperatures statewide is favored by the CPC. Below normal precipitation is favored by the CPC for Central and Southern California, and then there's about equal chances of normal precipitation in far Northern California near the Oregon border. And with that, I'll stop.
Great. Thank you so much, Nate. We did have a few questions there, guys, but since we are over on time, if you could go ahead and go to the Q&A and type in the answers, that would be appreciated. Thank you so much.
All right. Thanks, Ron.